Welcome to a new Geant4 video on my YouTube channel Physics Matters. Today I would like to continue with our project that we have started last time and now fill it with life, so to say. I want to add a few things that we need in order to create a setup, a simple setup for gamma spectroscopy. And for this we need a sensitive detector as well as some modifications in the detector geometry. All this is not so much critical and difficult, but you will see that at the end, after doing that, it will give us a lot of benefits in the future as well. So in order to do these changes, first we have to go to our source folder and go to our primary generator class that we have defined previously. And because we want to make gamma spectroscopy, we have to change the primary particle from positron to gamma. And the energy we also have to reduce to mega electron volt, just because when we take, for example, radioactive decays into account, then the energy is much smaller. And also what we can do with Geant4 is we can simulate radioactive decays. However, in this video now I would like to concentrate only on the particle gun to shoot gammas. But later, in one of the next videos, I will also show how you can simulate radioactive decays. And one more thing which we have to change is our PZ value, our momentum coordinate in Z direction. So here we have to write 1 just to make sure that our particle is shot straight forward in Z direction. So in order to calculate the deposited energy in a detector, the easiest way from my point of view is to create a sensitive detector. You can also define a scoring volume as we have done it in the previous tutorial, but now let's do it directly with a sensitive detector. So in the include folder, we create a new file called pmsensitivedetector.hh. And then here in this one, we first have to use our standard way of protecting it by writing if not defined pm sensitive detector _hh, and then we can copy that and change this to define, and then we have to end our if condition to make it complete. And now then when we have done that, then now we can actually start now with the include files that we need. And the most important one is our G4V sensitive detector. This is the base class provided by Geant4. From this we have to inherit and then change it accordingly. And then what we also have to include for later purposes, this is G4 system of units and G4 units table.hh. So we can also use units like millimeter, mega electron volt, and so on. And now after doing that, we can now finally start with the definition of our class, or with the declaration of our class. So we can write here sensitive detector, and as I said, we have to publicly inherit from G4V sensitive detector. And then we can start with our public functions, and there we have only our constructor, which is pm sensitive detector, and also our destructor pf sensitive detector. And now we can start with our private member functions and variables, and there we have a few. So the first one is a double value, G4 double, and I call that f total energy deposited. This will be our total energy which is deposited per event in our sensitive detector. And then we need some virtual functions. We need virtual void initialize, and this function initialize is always called by Geant4 when a new event starts. So we need that. And we also have to include one parameter actually, which is G4HC of this event. There's an object from a class G4HC of this event, and HC stands for hit collection. So we can use this to create hit collections. We don't need to do this in our detector. This is only important when you really want to do analysis and reconstruction within Geant4, or you want to add some electronic noise, dead times, and so on. But all this we don't want to do. We really want to keep it simple, but nevertheless we have to include it, otherwise it does not work. And the next one is called end of event. So here we also have to do the same, G4 HC of this event. And end of event, this function is of course always called when the event is completed. And now the next one and the last one and the most important one is called, it has a return value of bool. Yeah, so we have to write here G4 bool. And this is called process hits. And this is the main function which handles whatever happens during the time when a particle is inside this detector. So for every step which passes, you can get some information from that particle. So in order to do this, you need access to the step. So you have to write here G4 step. This is the class which handles the steps by Geant4. And then we also need another object here from a class called G4 touchable history. And this actually gives us access to the volumes if we need it. At the moment we also don't need it, but we have to insert it, otherwise it does not work. And here we also want to override the functions that are already included, so we have to write here 2 times override. And then at the end we have to make a semicolon to close our class declaration. Yeah, and one thing which I have forgotten in the constructor, we have to hand over a G4 string as well. This is the detector name, as we will see later. Yeah, but now after completing this, we can now go to our source folder, and there we can create a new file called pm-sensitive-detector.cc, and then we can include our pm-sensitive-detector.hh and start with our definition of the different functions and different functions. So we will start with the constructor pm-sensitive-detector, pm-sensitive-detector, and we also can write here once more inherited from G4v sensitive detector, and here we have to write our G4 string, and we call that variable name because it's a name. Yeah, and then what we want to do in the beginning when our constructor is called, our object is created, so we want to write here f total energy deposited equals to 0. Yeah, to make sure that in the beginning there is no problem. Yeah, and here we have to of course also write name. Okay, so now in the next step we want to define our destructor pm-sensitive-detector, and this will be empty. There we don't have to do anything. And then we start with our functions, in this case our initialize function, so pm-sensitive-detector, and we call that initialize. And then here, if a new event starts, we also have to reset our total energy deposited back to 0 actually. And here we have to insert our G4 HC hit collection of this event. And we don't need this, so I don't need to create any object here of that which we can access, so we can just let it like that. Then we can also create the other function, end of event, and again we have to write G4C of this event, and then here we have to write at the end of each event we want to write out the total energy in the terminal. So here we can write G4C out, and for example deposited energy, and then F total energy deposited, and G4 end line. Yeah, this is in principle everything which we need. And now the main part comes, which is G4 bool, as I said, and this is process PM sensitive detector, process hits, and again we have to include here our G4 step, and we have to access this, so we have to give it a name, a step for example, and G4 touchable history, and this we could for example just call touch hist. At the moment we don't need it, so we can even let it empty for the time being. So now we continue with what should happen inside, and we can define a new variable here, which is a double variable, and we call that F energy deposited maybe, and this is equal to a step get total energy deposit. So you can see this is such an important value, the deposit energy, that Geant4 even provides an own function, member function, to get access to that. Yeah, and then we can write one thing more. We can create an if condition here and write actually if F energy deposited is larger than 0, then in this case our F total energy deposited should be increased by this energy deposited. Yeah. So what we do now, in every step where the photon loses energy, this energy which is deposited in this scintillator is added to the total energy deposited, and this is then at the end of each event given out. So now we see how much energy is actually completely deposited in our detector. And I think this is everything what we need. So as usual, we can go to our build folder. Now we have to run cmake ... to make sure that it finds the new files that we created. And then we can simply type in make to see if we have done any mistake. Yes, and here we can see something which I have also forgotten in the previous tutorial. Process hits is a G4 bool. So we have to now give a return value, and this is true, otherwise it might still work because it's only a warning message, but it can lead to problems later on. So it's very important to take care of that, and this is also the reason why I say that it's better to compile the program immediately when you do some changes, because then you can see whether there are some warning messages that appeared. So now we have completed that, and now we can continue with actually implementing the sensitive detector in our geometry. Yeah, and for this purpose we go to our detector construction header file, and we have to add a few headers which I have not implemented last time because we didn't need it, but now we will need it. So what we have to implement is our visualization attribute. I will show you later for which reason we need it. So we can write here vis attributes.sh. Then we have to also include G4 color, because later we want to give every detector a certain color, just for make it easier visible. And another one which we have to include is to make sure that our detector works is the so-called G4 sensitive detector manager.sh. These we need. And then we can in principle start now to go to our source file, and then we check where we have created our world, and below that directly we can start in principle with the definition of our detector. But first we should define a few materials, and I would like to do that here in the beginning. So we want to include a lead absorber, and for this we have to write here find or build material, and lead is already implemented in Geant4, so we can write G4_PB for plumbum or lead. Yeah, and the next one which we need is let's call it detmut, and this is NIST find or build material, and this could be G4 sodium iodide. It's also implemented in Geant4, and we can just simply take this. Okay, so now we can really start with our volume. So we can first define a thickness of our lead absorber, and this could be lead thickness, and maybe we can just define this as 2 millimeter, and we can also define a LED size of maybe 5 centimeter. And then we can start with our G4 box, and we call that solid LED, and first solid LED, and then we can write here new G4 box, and then first we have to give a name, so it would be solid LED, and then we have to give the size, so we can write here 0.5 times LED size, and here again 0.5 times LED size, and then 0.5 times LED thickness. And then we have everything included. Our definition is complete. Maybe I can increase the LED size to 10 centimeter because we always give half of the length and the height and the width here. Okay, and then we can continue with G4 logical volume. And here I would then call that logic LED new G4 logical volume. And then what we have to do here, we have to first refer to the solid. So we write here solid LED, and then we have to insert our material LED mat, and then we can call that logic LED, yeah, as we have done also several times before. And then we have to create our G4 physical volume, and this we call phys LED, and this should be identical to G4V PV placement, similar to what we have done for the world volume. And then we have to first insert a 0 here, because we don't want to have any rotation. And now the only thing which is important is our position, and this should be 0, 0, and then we can write here 5 times centimeter. Yeah, and this means that now this should be G43 vector, so it means now 5 centimeter in Z direction our LED block is created. And then we have to add a few more parameters. So it should be logic LED, our logical volume, the mother volume, or first we have to define the name. So we can write here phys LED, and then the mother volume, logic world, false, and check overlaps. Yeah. And then if we did everything correct, we can see that we don't get any error message. And we can also write make again once more to check whether it worked well, but I'm not expecting any issue. So this seems to work fine. And then I also would like to change the attributes of that. So what we can write now here, G4 attributes, and then we can call that LED with attribute equals new G4 with attributes. And then we can insert our color, G4 color here. And for example, if we want to make it red, then our first RGB value, which we have to insert, is red, and this has to be 1.0. Then we have to write 0.0 for green, and for blue again 0.0. And then we also want to define an alpha value, which should be 0.5, because we want to make it semi-transparent. And then we can write here LED with attribute, set force, and then solid, because we want to have it as a solid object, and this should be true. And then we want to assign it to logic LED, so we have to write here logic LED set with attributes, and then we have to write here LED with attribute. So this seems to be fine. Now we can compile it, and after that we can test it to check whether everything is fine. Yeah, and now I just run it, and we can see here yeah, our world volume is also still there. And then inside this we have here our box, which is actually lead. Yeah, and now we continue with the detector. So we can write here G4 box and then solid detector equals new G4 box. And then, similar to what we have done before, we can first define a few parameters. For example, we can write here G4 double, and then we can write detector size. And this should be, for example, again 5.0 centimeter. And we also have to multiply that. And then our G4 box, the name should be solid detector. And then our detector size, and detector size. So we want to have all sides with the same length. And just to be consistent, let's change it again to 10, and then we can write here 0.5 times that, 0.5 times this, and 0.5 times this, because as I said, we have to insert the half length here. Okay, so now what we can do is the next one, the logic detector. For this we have to take care now, because we want to access the logic detector outside of this function here, of the construct function. So what we have to do, we have to go to our header file now, and here we can create a private environment, and then we can write here G4 logical volume, and then we call that logic detector, for example. And then we go back here to our detector construction file, and then we can refer to that and write here just logic detector equals new G4 logical volume. And then we can do it similar to what we have done before. We write here solid detector, because this is our solid, and then we have to give a name. Or first we have to define the material, which would be dead mud, and then we have to give a name, so we call that logic detector. Yeah, and then in the next step, what we have to do, we have to create our physical volume, so we have to write G4 physical volume, and this should be named phys detector. And this should be equals to new G4 PV placement. And then again, to what we have done before, we have to insert our rotation, which should be 0. Then our G4 3 vector, which could be now given as, for example, 0, 0, and 10.5. So we want to shift it 10.5 centimeter into Z direction, and then it should be referred to our logic detector, and we call that phys detector. And again, our mother volume should be logic world, and then the next parameter should be false, and the last one should be check overlaps, and then we can finalize this. And now again we can create some visualization. So we can write here G4 vis attributes, and now we call that this vis at, and new G4 vis attributes. And now again G4 color we can insert here, and this should be maybe yellow, so we can write 1.0, 1.0, and 0.0, and 0.5 for the alpha value. Yeah. And now we can write here that with attribute, and we can call the function here set force solid once more, true. And at the end, what we can also do is we can write here logic detector set with attributes, and then we can assign that by writing that with attribute. And again, we can try to compile it to check whether we have done everything correctly. Now we can actually also test it, and what we can see here now is that we have here our LED, which is in red, and we have this sodium iodide detector behind that. And now the only last thing which we have to do, we have to assign our sensitive detector. So what we can do now is we go to our header file, detector construction, once more, and there we have to create in the private environment a new function, a virtual function, which would be virtual construct SD and field. And this function is very important because SD stands for sensitive detector. So this constructs now any sensitive detector or any additional field like electric or magnetic field that we want to apply. Yeah? But this field we can ignore, we can only concentrate on sensitive detectors actually. And of course we need, it has no return value, so we can write here virtual void. Yeah, and then now we can go back to our detector construction.cc, and then finally we have to create our function here, we have to define it. So we can write here void and PM detector construction, and then the name was construct SD and field. And now we have to fill in our definition of the sensitive detector. So we have to get access to our PM sensitive detector, and for this we have to also include this in our detector construction, this header file. So we can write down here include PM sensitive detector HH, yeah? And then we go again here to our source file and we write here PM sensitive detector, and we can call it maybe sensstat new PM sensitive detector. And as I said, we have to hand over a name for the constructor, and this we can just maybe call sensitive detector. At the moment it does not so much important, we can just give any random name. And then we can use our logic detector and write here set sensitive detector. This is a function, a member function, and then we can apply our sensstat to that. And if we have done this, then there's only one last step which we have to do, and this is to get a pointer for our sensitive detector manager. So we have to write here G4 SD manager and then get SDM pointer, and then we have to write add new detector, and then we have to insert our sensstat here. And the reason why we have to do this is because we want to make sure that our functions initialize and end of event that we have defined previously, that they are called. And this only works if we add this to this Geant4 sensitive detector manager, otherwise it doesn't work. Yeah? But when we have done this, then in principle everything is complete. We can compile it, and again, if we didn't do any mistake after that, we would be able to test it. So we have here our sodium iodide detector and our LED absorber, and now we click here on this green button for run on, and we can see that there is one photon, one gamma entering our detector. And inside the detector, it seems to be scattered. Maybe it is doing Compton scattering until finally it is absorbed. However, the deposited energy here is written as 1. So it means the total energy is 1, and the standard unit in GS4 is MeV, mega electron volt. So the same energy that we have created before, 1 MeV, is also deposited in our detector. Everything is perfectly fine. It seems to match very well with our expectation. Now we can also maybe run beam on 100 photons, and now we can see it looks a little bit different. We can see some of the photons enter, then they are scattered within the scintillator, and also some of them leave the scintillator. They do not interact with it at all. And some of the photons also stuck maybe in the LED absorber. So when we go down through the list of deposited energy, we can see that here some of the events we have 1 MeV, and this is where the photon loses its complete energy in the detector. In some cases we have 0, and this is where the photon leaves the detector. And for some we also have a fraction of that, so maybe the photon does some Compton scattering inside the detector and then leaves it. Yeah? So now we could histogram these entries, for example with root script or with a Python script, and then further analyze this further. This I can also show later how to do this with Geant4 with the analysis manager, but this will be part of another video to not exceed the limit of that one here. Yeah, but I think you learned a lot already, and I think now you are able to modify your geometry, your physics list, your particles that you want to create, and in principle you would be able to change it to any setup, whatever you have in your lab, and you can simulate this. If you have any further ideas, suggestions, comments, and so on, please write it in the comment section. I will try to also take this into account, but I think we have a quite good starting point already. Yeah, thank you very much for your attention. I hope that you enjoyed it, you learned something new, and see you for a new video. Thank you very much for watching this video. If you like the content and want to see more of it, please like and subscribe. And in addition, any kind of support is always appreciated.